Hi, my name is Nurul Shahda binti Abdullah. My matrix number is 01DE24F102. Today I'm going to verify and introduce the bipolar junction transistor BJT and its significance in electronics. What is BJT? BJT is a three-terminal semiconductor device used for amplifying and switching electric signal. The three-terminal is emitter for release charge carry, base control the transistor operation, and collector for receiving charge carries. Then I'm going to explain the signification in electronicity. One is amplification, which is for use in audio amplifier, radio circuit, and signal processing. Two, switching, which is for function as an on or off switch in digital circuit. For oscillation and signal modulation, is for incidental for communication system. For voltage regulation, which is help stabilize voltage in power supply. BJT were fundamental in early transistor-based electronics and are still widely used in low power application. Then I'm going to state the objective of the experiment 3. The objective of the experiment to investigate the characteristic and function of a bipolar junction transistor BJT by analyzing one BJT terminal to understand the role of the emitter E, base B, and collector in transistor operation. 2. To analyzing BJT type, which is to differentiating between NPN and PNP transistor based on current flow and charge carry. 3. Is material in BJT, which is examining the semiconductor material used, typical silicon or germanium, and their impact on transistor performance. The experiment aims to develop practical knowledge of BJTs by exploring their construction, electrical behavior, and application in electric circuit. Then I'm going to explain the type of BJT. There are two main types of BJT. One is NPN transistor. The structure is it has a layer of P-type material between two N-type material. The current flow, when a small current into the base, is allowed a large current to flow from collector to emitter. The operation is the transistor turn on when a positive voltage is applied to the base. The use is commonly used in amplifier and switching circuit. 2 is the PNP transistor. The structure is it has a layer of N-type material between two P-type material. The current flow is when a small current into the base is allowed large current to flow from emitter to collector. The operation is the transistor turn on when a negative voltage is applied to the base. The use is commonly used in complementary circuit with NPN transistor. Then I'm gonna tell the difference of current flow direction and biasing condition. First is current flow direction for NPN transistor. One is current flow from the collector to emitter when the transistor is on. 2. Electron move from emitter to collector. See, electrons are the majority charge carrier. For PNP transistor, 1. Current flow from emitter to collector when the transistor is turned on. 2. For the holes move from emitter to collector since holes are the majority charge carrier. So, the key difference in behavior. 1. NPN transistor require a positive voltage at the base relative to the emitter to turn on. 2. PNP transistor require a negative voltage at the base relative to the emitter to turn on. And lastly, due to high electron mobility, NPN transistors are more commonly used in digital circuit and amplifier.
Next, we go through how to decide BJT polarity. First, reverse the multimeter probe. Second, using the multimeter on branch 10, check the BJT continuity and determines its terminal. When you use the multimeter, we can identify the types of transistor. If the polarity of the probe that touch the base is positive, then the transistor is NPN type transistor. With this, with the reverse polarity, it indicates PNP type transistor. Then, if we use the multimeter, we can also decide. We can identify the collector or emitter terminals. The terminal that give a lower resistance is the emitter, which the higher one is the collector. Then, we can identify the silicon or germanium type of transistor if we use multimeter. Then, we move to tools that we use to get output waveform. First, function generator. Function generator give wave signal and frequency to display it on oscilloscope. 2 is power supply. Power supply will supply voltage or current to load in any circuit. Third, oscilloscope. Oscilloscope will display waveform signal. That's it. Thank you.